April 16th. For most of us, it's just another day on the calendar, right? But in the history of mathematics, this one day holds an incredible secret. It's like a golden day, a day of pure genius.
It's pretty wild when you think about it. On this exact date, but separated by centuries, three brilliant minds either began or ended their journeys. And each one of them left behind ideas that completely reshaped how we see the world. I don't think that's a coincidence. It feels more like a convergence of genius.
So this timeline here is going to be our map for this little journey. We're going to dive into three key moments, all tied to that one day, April 16th. And our first stop, it's with a guy who's somehow managed to find order in complete chaos.
All right, so our first story is about a man named Edward Lorenz. And he tackled a huge, very modern problem, the limits of being able to predict, well, anything. And his mystery really starts with a question I'm sure you've asked yourself. Why is it that a tiny, tiny little change in the weather forecast, something you couldn't even measure, can lead to a totally different result just a week later? I mean, how does a prediction for a beautiful sunny day suddenly turn into a massive storm, all because of some tiny little shift at the beginning?
Well, the person who figured this all out, he passed away on our special date, April 16th, 2008. His name was Edward Lorenz. He was a meteorologist and a mathematician. And get this, he almost stumbled onto one of the biggest ideas of the 20th century completely by accident.
His discovery was absolutely revolutionary. I mean, it shattered what scientists had believed for centuries. For ages, everyone thought, hey, if we just know all the starting conditions, we can predict the future perfectly. Simple, right? But Lorenz found that these tiny, almost invisible changes in his weather simulations produced wildly different results. He gave it a very technical name, sensitive dependence on initial conditions, but that idea, that's the foundation of what we now call chaos theory, and it's absolutely crucial for how we forecast weather today.
And he summed up this massive idea with one single, now famous question. You've probably heard it. Predictability. Does the flap of a butterfly's wings in Brazil set off a tornado in Texas? The answer he found was just as mind-blowing. It was maybe.
Okay, now let's jump back in time a bit. We're sticking with April 16th, but we're heading to 1998 to meet a totally different kind of mathematical genius.
This next story kicks off with a pretty challenging question. What if the most brilliant answer to a problem isn't the one that's sitting in the textbook? What if real genius is all about ignoring the path everyone else takes and blazing your own trail?
That was pretty much the life philosophy of Alberto Calderón, who also passed away on April 16th back in 1998. This was a mathematician whose brain just operated on a whole other level.
Oh, and the story about how people discovered his genius is just legendary. So as a student, his professor, a famous guy named Antoni Zygmunt, asked him to present a proof from Zygmunt's own textbook. But Calderón doesn't just read it back. No way. He gets up there and on the spot invents his own proof, a shorter, more beautiful one. Zygmunt was so blown away by this raw talent that he immediately invited him to study in Chicago. In fact, Calderón was so obviously brilliant that when it came time for his PhD thesis, the department chair just took 3 of his published papers, stapled them together, and said, "There, that's your thesis."
So what Calderón's story really teaches us is something powerful, right? The most important discoveries aren't the ones you just read in a book. They're the ones you figure out for yourself.
One day, so many incredible stories. For our last stop on the timeline, we're going to take a much bigger leap back in time. We're going to uncover a secret that was hidden away in the quiet life of a simple country priest. And you know what? This last mystery feels more important today than it ever has. The question is this: how on earth do you find a simple, clear pattern when you are drowning in millions or even billions of pieces of data?
Believe it or not, the answer comes from a quiet country priest, born on our special day, April 16th, way back in 1873. His name was Alfred Young, and he was secretly a total master of abstract algebra.
So while he was taking care of his parish, Young invents this incredibly powerful visual tool back in 1900 called Young Tableau. Now, think of these things like special diagrams, a way to organize absolute chaos and see hidden patterns inside big groups of numbers. In a time with no computers, he basically created a system to manage massive complexity, a concept that's at the very heart of big data today. His methods became absolutely fundamental to something called group theory, which is really just the math of symmetry, and they're still used in high-level research.
But you know, what I think is the most amazing part are his own words about his work. He once wrote,
I am delighted to find someone else really interested in the matter. Wow. It's just such a powerful reminder that even when you're working on something truly revolutionary, it can feel pretty lonely. But it's always, always worth it.
So let's recap. We've got a meteorologist who saw the future in a butterfly's flight, a prodigy who just rewrote the textbook on the fly, and a quiet priest who figured out how to decode overwhelming complexity. They're all connected by this one day, April 16th. But what's the real thread? What's the deeper connection that ties all their work together?
So take a look at our timeline now, all filled in. Lorenz, Calderón, and Young. The thread connecting them, it wasn't just the date. It was a shared kind of genius, a genius for finding beautiful, simple patterns inside of overwhelming, messy complexity. Right? Lorenz found the hidden pattern inside chaos. Calderón found the simplest, most direct path through a logical maze. And Young, he created a whole new visual language to see patterns that were invisible to everyone else.
Every single one of them, in their own time, stared right into the face of chaos, and they saw the beautiful patterns hiding just beneath the surface. And that, of course, leaves us with one last, really big question. They found the essential patterns for their time. So what are the crucial patterns that we might be completely missing today?